Hello friends, welcome to my channel. In this video we are going to discuss about 4-bit binary adder subtractor. So observe here. So the addition and subtraction, it can be performed in the single circuit diagram. So observe here the internal circuit diagram, how it is. So full adder 0, 1, 2, 3, it is a 4-bit. So 4 full adders, and the respective sum outputs S0, C0, S1, C1, S2, C2, S3, C3, the full adders outputs. And the point is here, the A0, A1, A2, A3 are the 4 bits, and B0, B1, B2, B3 are the another 4 bits. But here the B0 value, which is not directly, which is taken with the help of XOR gate, we are used here, right? So the XOR gate, one input is B0 and other input it is given to it is actually given to a control input M. The control input M or Cn, both are same here. So based on this control input signal will decide whether it is to perform addition or subtraction. The point is here, if the control input M it is 0, let us assume M it is 0. That means if M it is 0, ultimately what is it is happened, Cn is 0. So that is what I mentioned here. If M is equals to 0, that means Cn is 0. So because of that, XOR gate one input is 0 and other input is B0. So in that case, here we are getting addition operation, it is going to be performed. The circuit it will perform addition operation when the control signal is 0. When the control signal is 1, the circuit it will behave as a subtractor operation, right? So that means M is equals to 1 in the sense Cn is also 1, right? As we discussed, Cn is 1 in case of subtractor, 4-bit subtractor, and Cn is 0 in case of 4-bit binary addition, binary adder, right? The same thing it is going to be done. So because of this, control signal will decide whether it is to perform addition or subtraction. So to understand this concept, now let us observe here. We need to understand the XOR gate truth table. So this is the XOR gate truth table. So 0, 0, 0, 1, 1, 0, 1, 1 case, the output is 0, 1, 1, 0. This is the XOR gate output. The point is here, if XOR gate, so here the XOR gate it is 0, let us assume if the control input is 0. That means if the control input is 0, here 0, here 0, this will be 0 and this will be 0, and Cn also 0. Let us assume here the control signal which is 0, the Cn is 0, and this XOR gate inputs are 0 and other inputs are B2, B1, B2, B3 respectively. Now observe here, let us assume our A is a control signal here. So if the control one input is 0, control signal which is 0 here, and observe the B values, 0 here, 1 here. So the point is here, the control signal it is 0, irrespective of the B value, the output is B itself. The output is B itself. So control signal is 0, if B value it is 0, output is 0 itself. If control signal it is 0, if B value it is 1, the output is 1 itself. That means it is act like a, we can say this is nothing but act like a buffer. So this we can call it as a buffer. If the control signal it is 0, this XOR gate act like a buffer. The same, whatever it may be the input, that is reflected back to the output side, right? So that means in this case, if the control input is 0, here we are getting the output is B3 itself, this is B2 itself, this is B1 itself, and this is B0 itself, right? So B0, A0, B0, A1, B1, A2, B2, and A3, B3. So that means control input 0, it is just like a addition operation, right? The same thing we discussed here. Next thing, if control input is 1, observe this case. If control input is 1, the B value it is changing, whether it is 0 or 1. If the control input is 1, the B value it is 0 in the sense the XOR gate output is 1. If control input is 1, if B value it is 1, the XOR output is 0. That means it is act like a inverter, completely opposite to the this one, buffer. So if B value is 0, the complemented output we are taken. If B value it is 1, the complemented output we are taken here. That means as we discussed in our 4-bit binary subtractor, b complement we are taken by using NOT gate. The same thing it is happening here. So because of this XOR gate, it is performing complement operation when the control input is 1. When the control input is 1, the Cn it is also 1. So that is the reason it is act like a subtractor. So this is the circuit diagram, and this is the some internal operation. So, and this is the overall block diagram. This is the 4-bit parallel adder subtractor, and you can observe here the 4 XOR gates. So the control signal it is m, let us assume. So if it is the m equal to 0, right, if m equals to 0, if one input is 0, so all these XOR gates, the input is 0 like this. So anyway, if control signal is 0 in XOR gate, the output is b0 itself, here b1 itself, here b2 itself, here b3 itself. So here Cn is also 0 when the control input is 0. Now in the second case, let us assume if control input is 1, let me take with if Cn is equals to, Cn it is also changed to 1, because when m equal to 1, because of this this output it is changed to b0 bar. So let me write here b0 bar, let me write here b0 bar, and this one is b1 bar, and this one is b2 bar, and this one is b3 bar when the control input is 1, right? So because here m equal to 1, so that means observe here, this is just like a subtractor operation it is going to be performed, and anyway it is carry outputs and it is the sum outputs. So hope you understand this. This is the important one. So the 4-bit binary adder and a subtractor we are going to perform with the help of this XOR gate. So I hope you understand this video. So please like, share and subscribe my channel, and also forward to this your friends also. Thank you.